go there. This is going to be simplifying complex fractions. This is specific to my transition to college math class. This is section 8.5. But if you just generally need to know how to, how to simplify a complex fraction, here's the way that you would do it. There is more than one way to do this. The first way involves kind of more work than I think is worth. It's finding an LCD and then changing the denominators and then getting like and having fractions. But I'm going to teach you the method where you find the LCD and you use it to eliminate the majority of the fractional pieces. So I'm going to do a couple of examples. You also have a worksheet, and I'll do a couple off of the worksheet, or at least one off of the worksheet. But I'm going to show you the method that I think works best for simplifying complex fractions. A complex fraction is quite disgusting because what it is you end up with a fraction or several fractions on top being divided by a fraction or several fractions on the bottom. So you have fractions in the numerator, fractions in the denominator, and this is just a numeric one. And this one, like, you could plug into one of the current calculators, and provided you put it in correctly, it would solve it for you. But I'm going to show you a method that will work for numbers, and it will work for variables and polynomials, and it's all going to kind of go back to LCD. All right, so the first thing that you want to do, I apologize, my cat has come into the room and she is full of meows. So if you can hear meowing, it's the cat is here. The first thing you want to do is find the LCD. Now, here's the trick. We actually have 4 denominators. We have 4, we have 3, we have 2, and technically, this guy's over 1. So I'm going to list out my prime factorizations for 4. That'll be 2 times 2, which is 2 squared. 3 is just 3, 2 is just 2, and 1 is just 1. So now when I look at my list, I don't need to include 1, but I can. I'll get 1 times. These both have 2's, but I'm going to pick the bigger 2, so I get 2 squared. And then 3 is unique, so 3. That'll give me 12. Right, now, here's the part where it gets weird. You're going to multiply the top and the bottom of the complex fraction by the LCD. And so what I mean is, I'm not going to turn this into 12 and this into 12 and this into 12 and this into 12, because you can do that and it just will take forever. What I'm going to do is I'm going to do a shortcut, and this will help also when we solve. I'm going to multiply the top through by 12 and the bottom through by 12, and watch what happens, okay? When you multiply a whole number times a fraction, it multiplies to just the top. So 12 times 2 is 24. Now, you might be like, okay, great, Siddig, we still have this gross thing here, which is true, but because this is an LCD, it's going to get 24 over 3, which will reduce to a whole number. All right, when I multiply here, I get 12 times 1, which is 12, over 4, which is still a fraction, but will reduce to a whole number. Okay, when I multiply here, I get 12 times 2, which is 24. And you could leave the 1 on the bottom, you don't need it. I'm sorry, my cat just literally ran into the stand, so if you notice some wobbling, she is apparently desperate for attention. 12 times 1 is 12 over 2. Now, it seems like I just made it worse because I still have fractions, but what's going to happen is, because we used the LCD, every single fraction is going to simplify. And it's going to give us whole numbers, or in the case of like when we're dealing with polynomials or monomials, it's going to cancel any fraction we have, and we're just going to get whole terms as opposed to fractional terms, okay? So after you multiply through, you reduce, and then you solve the problem. Okay, so I'm going to erase my definition and my top piece here so that I can finish the problem up at the top. All right. 12 divided by 4 is 3. 24 divided by 3 is 8. 24 is just 24. 12 divided by 2 is 6. 3 plus 8 gives me 11. 24 minus 6 should give me 18. Let me double check that. Yep. So my answer is 11 over 18. Okay? You can do that, like I said, by turning all of these into 12. So multiplying this by 3 over 3, this by 4 over 4, this by 12 over 12, this by 6 over 6, and then reducing it. But I think it's so much easier and so much faster to go ahead and just multiply through by the LCD, because everything will turn whole number or whole term, and you will be done with the problem much faster. All right? So the next one I'm going to show you has some variables in it, but what you'll see is it follows the same pattern. Okay? So if you need to still get this, if you need the steps, go ahead and pause and copy what you need. When I am back, which hopefully will be tomorrow, which is Friday, not tomorrow because it's only Wednesday now, but tomorrow in your town, we can review and go over stuff. And I apologize, I went to the doctor today and got scolded for trying to do too much too soon. All right, next one. So I think I'm going to do one more in my notes section, and then I'm going to pull a couple from the worksheet to do together. All right, this one says 5 over a squared b divided by a over b plus 1 over a. Okay, now, most people when they see a problem like this would immediately skip it because it looks absolutely disgusting. But what we're going to do is we're going to find the LCD, we'll multiply the top through by the LCD and the bottom through by the LCD, and we will eliminate every single fractional piece. Okay, now, this has 3 denominators. It's got a squared b on the top, it's got b on the bottom, and a on the bottom. So notice, 1 fraction on top, so 1 denominator, 2 fractions on the bottom, so 2 denominators. A is just A, sorry, B is not A. B is just B, and A squared times B is just A squared B. So my LCD, they have the A in common, this one has more, so we get the A squared. They have the B in common, and they both have 1, so we get B. So now what I'm going to do is I'm going to multiply the top times A squared B, and the bottom by A squared B. And here is the beautiful thing. This is exactly the same as this. So I'm allowed to take and divide them because they're completely identical, and that reduces to just a 5 on top. Do you see how fast that happened? Because we used the LCD and we knew that it would reduce the denominator, this one happened to be identical, reduced the whole denominator, we were literally just left with the 5. Now, this one's a little bit trickier. This one I'm going to have a squared b times 1, which is a squared b over a. However, we know, because these are both a's, that we can reduce them and get rid of this a in the denominator. Okay? This one I get a times a squared. Remember, add the powers over b divided by b. So here, the b's are going to reduce. Here, I'm going to lose an a on each. So I'm going to end up with 5 over a to the third plus ab. Now, here's the trick. A to the third and AB both have A's in them, but to add, they have to be exactly identical. And because this is an A to the third and this is an AB, they're not exactly the same numbers to the same, or the same variables to the same powers. So that is our reduced answer. Okay? It is super bizarre. Okay? It's not something that I think that you would look at and think like, oh yeah, I'll totally just find the LCD and multiply. It's going to be a challenge. You know, just do your best with it. Some of you I know will be fine with it. Some of you might have some challenges, but you have to practice it because there's no real other way to deal with complex fractions. All right, so now I'm looking at the worksheet. So if you are in my transitions class, this is the worksheet you should have gotten today called Simplifying Complex Fractions. I'm just trying to think what would be a good one to do. Maybe let's do maybe number 6 because it looks a little strange, and then maybe I'll do a slightly harder one afterwards. And I apologize, I'm in some pain here, and so if my focus is lacking, it's because I'm ready to lay down. All right. Okay, so let's look at problem number 6. 6 is one that I think is a little weird, and it also could be a little deceptive because of the way that it's written. So we have 5 over. So notice the top does not have a fraction. It is just a whole number, and that's okay. We won't use it for LCD. All right, then on the bottom we have u over 5 minus 25 over u minus 3. And here's the beautiful thing, and I'm going to put a parenthesis around that because it's a binomial. Here's the beautiful thing. We are going to find our LCD, and we don't need to include the LCD in the top because the LCD of the top, or the denominator of the top, is just 1. Okay, so our LCD is going to be a 5 and a u minus 3. The only factors of 5 are 5 and 1. U minus 3 is unique, so our LCD is going to be 5u minus 3. Okay, now even though the top is not fractions and we didn't technically use it for the denominator, when you multiply a fraction, you have to multiply the top and the bottom. You can't just be like, oh, well, I want to get rid of just the denominators in the bottom, so I'm going to multiply only the bottom. I mean, you could, but you wouldn't be doing the problem correctly. So I have to multiply the top times 5, u minus 3, and that's okay. And then I'm going to multiply the bottom times 5, u minus 3. Okay? When I carry this in, I'm going to get, sorry, I should do the top first. 5 times 5, u minus 3, and I'll multiply those. Then I'm going to get 25 times 5, u minus 3, over u minus 3, and that's lovely because the u minus 3s are going to reduce. And then I get u times 5 times u minus 3 over 5. And this one will look a little grosser because only the 5s will reduce. But we're just going to kind of simplify where we can. So I'm going to come back in. The u minus 3s are going to reduce. The 5s are going to reduce. On top, I'm not going to get real complicated. 5 times 5 is just 25. U minus 3. Now on the bottom, I have to be a little more careful because this u is going to multiply in. And I don't think I'm going to have any like, but we'll check it out. I'm going to get u squared minus 3u minus 25 times 5 is 125. We could try to factor that. I chose this one. Remind me of that as I'm doing it. Like, I chose this one. 1 and 125. 2 doesn't go in evenly. 3 goes in 75 times. Not 75 times. 3 does not go in because 3 goes into 12 evenly. 4 does not go in. Sorry, my tummy area hurts. 5 definitely goes in. 6 does not go in. 7 will not go in. 8 will not go in. I don't think anything is going to go in. And guess what? If something does go in, you find it and tell me about it tomorrow. I'm too tired. Normally you would factor it and see if anything else reduced. But for now, I don't think I'm going to get 3 in there. Therefore, I don't think this is going to factor nicely. So I'm finished. Okay? So what happened is this piece that was left multiplied to the 125, and this u distributed to the u and the 3. That's where I got the u squared, u times 3 gave me the 3u, and 25 times 5 gave me the 125. Okay. Oh, I don't think I can do another one. I'm sorry. I have to sit. Do the best you can on this. When I'm back, we will obviously be doing quite a bit of review. I apologize for appendicitis. This was definitely not in my plans. I hope this sort of helped with simplifying complex fractions, and just take it piece by piece and really look at the LCD and getting rid of what you can. Do your best on this, and what you'll see is as we move forward to solving, it will really help us with solving. All right, have a great rest of your day.